This sequence of lessons is going to be on the bonding topic. I would argue the bonding topic is probably the most important topic of GCSE chemistry. It underpins all of the other topics, or most of the other topics you're going to study through the course of the 2 years, and you're guaranteed to get a heap of marks on this topic. Before we start getting into the detail of ionic and covalent and metallic bonding, it's really important that we understand that bonding is in two major groups. We've got giant structures and we've got simple structures. And I'm going to take you through what I mean by that, and how whether something is giant or simple gives it its essential properties that we can talk about. So first of all, we can just clarify what we mean by simple and giant. So a giant structure is one where we've got lots and lots of atoms or ions held together. So bonding is just this idea of how atoms or ions are held to one another. If it's a giant structure, you've got lots and lots and lots of them, trillions of them in either 2 or 3 dimensions depending on the structure. And so it could be this type of structure, which is metallic, that we'll discuss in a minute in detail. An ionic structure, this is meant to be in 3 dimensions, but I can only draw it in 2. This is what we call giant covalent. There's a number of giant covalent structures you need to know. Or we've got simple structures where we've got atoms held together in small groups of 2 or 3, or sometimes quite a few more than that, but in the end they're really quite a small group compared to the other structures here. And let's go through each of those in turn and consider how their structure relates to the properties. Now, with all of the giant structures, the melting points are extremely high. We're talking in the very high hundreds or potentially thousands of degrees. So the reason the melting points are high for all of these types of giant structure are that you've got lots and lots and lots of strong bonds, strong metallic bonds, strong ionic bonds, or strong covalent bonds that requires an enormous amount of energy to overcome. And to melt those structures, you have to overcome those bonds. Right, so they all have enormously high melting points, and we'll practice the language we use in the exam there in a moment. All of the simple structures, which are always simple covalent, small groups of non-metal atoms, when you melt or boil simple covalent structures, you don't break the bonds between the atoms, but you do overcome these weak forces between what we call the molecules, and those are called intermolecular forces. So for this group here, the simple structures, they all have very low melting points in comparison to all of the giant structures. So you have to be able to categorize any substance you're told about in an exam and decide whether they're first of all giant or simple, and that will allow you to understand the properties, and then we can work out a bit more detail about each of those in turn. So if you've got simply any metal you like, it could be zinc, it could be aluminium, it could be lithium, it could be gold, that will always have a giant structure. So it will always be giant metallic. I don't want you to talk about something having metallic bonding. I only want you to say giant metallic, because that way you're reminding yourself that it must have a giant structure. If it has a giant structure, it must have a high melting point. So relatively speaking, all metals have high melting points. And what you would say is because they have lots and lots of strong metallic bonds that require lots of energy to break. So forgive my writing there, but what I've said there is high melting point, lots of strong metallic bonds require lots of energy to break. So we're going to get full marks on when we're describing a metal. And we'll look at the detail of metallic bonding another time. If you've got metal and a non-metal, so it could be an aluminium with oxygen, or lithium with chlorine, which would be called chloride, or sodium and fluoride, as long as you've got a metal and a non-metal, and the ratio could be 1 to 1, it could be 2 to 1, or 3 to 2, whatever, as long as you've got a metal and a non-metal, it's going to be giant ionic. And again, I never want you to say simply ionic anymore, always say giant ionic, because then we know, it reminds us we've got a giant structure, it reminds us that it's got a high melting point again, and it has a high melting point because there's lots of strong ionic bonds require lots and lots of energy to break. So giant ionic, high melting point, lots of strong ionic bonds, and it says etc. there, require lots of energy to break. It's the same thing. When it comes to giant covalent, there are simply a number of structures you need to learn and memorise. And we'll go through each of those in turn in a separate video in detail. But you've got structures like this, which is diamond, which has lots of carbons attached to each other, each carbon making 4 bonds. Or we've got graphite. This is a single layer of graphite, this would be graphene. But graphite's a number of layers of graphene lined up with one another. Again, there to melt graphite or diamond or the other one, silicon dioxide, you have to break these strong bonds. And again, what you would say is there's lots of strong, this time covalent bonds, and they require lots of energy to break. So this again this again applies to diamond and graphite and silica and graphene. So this is graphene. Graphite's lots of layers of that, and in those cases, again, lots of strong covalent bonds this time require lots of energy to break. The only thing that's changing in each of those examples is the one key word, the type of bonding it is. So if you can categorize your substance that you're writing about, it makes things really easy. So the ones you need to know, you see at the bottom there, diamond and graphite and silica and graphene. I'll just remind you at this point that there's a kind of subcategory of metals which you might have to write about. But we're going to cover those in a different video. So alloys are when you've got mixtures of 2 or more metals, or 2 or more elements, one of which is a metal, which changes the properties a bit. But essentially you've still got metallic bonding going on there. If you've got groups of non-metal atoms, you have simple covalent bonding. But before I get to that, I just want to remind you again here that metals, when they form ionic compounds, form positive ions. That's why the word metal has got a plus conveniently right in the middle of the word, and the word non-metal has conveniently got a minus in the middle of the word. So the non-metal, the oxide, the chloride, the fluoride, whatever it might be, has a minus in the middle of it. So metal and non-metal, it would be ionic. Okay, so as soon as you get plus ion and a minus ion. But though, if you've got a group of non-metal atoms, these would be held together by strong covalent bonds. But as I said before, those strong covalent bonds are not broken when you boil or melt the substance. If you have, for example, water molecules which are held together by covalent bonds, when you boil it, it doesn't turn into hydrogen atoms and oxygen atoms. That just doesn't happen. All you do is separate the water molecules from each other. So instead of being like this, well, let's turn them into water by adding an extra atom. And they're held together by these weak intermolecular forces. When you boil water, you break the intermolecular forces and you end up with individual water molecules, which I'm representing just with circles for now, away from each other, not touching, not held together, separate from each other. So you go from a gas, from a solid to a liquid to a gas much more easily. So you would say that simple structures, so this would be simple covalent, have weak intermolecular forces which do not require much energy to overcome. So that was a very brief overview of the kind of 2 major categories of bonding. So giant structures which have high melting points, and simple structures, the simple covalent structures which have low melting points and low boiling points. And you've got to be comfortable with that. Now in the following videos I'll talk you through in detail metallic bonding and how that works, ionic bonding and how that works, giant covalent substances we'll look at individually, and then simple covalent we'll learn how to draw dot and cross diagrams for those molecules like water and carbon dioxide, oxygen, and so on. And that's it. Thanks, hope that was useful.